Welcome to the third and final section of the video course, Advanced Tools and Techniques Beyond Base R. This section is on writing functional R. We'll begin this section by learning how to write our own R functions. Then, we'll learn about applying functions to lists of inputs, an important part of the functional programming technique. We'll revisit the Magritte pipe, and consider how to compose functions that you have written into tidy data analysis pipelines. Finally, we'll learn about R expressions and how to capture and modify them in the technique known as metaprogramming. This video is on writing an R function. In this video, you'll learn how to create a new function. You'll learn how to set the function's arguments, including default arguments, and how to handle situations where arguments are missing. Let's move over into RStudio. We'll be working in the source pane on the left-hand side of the screen. Creating a function in R is actually very simple. To begin, you need to give your function a name. Let's create a function that finds the square of a number. We'll call it square. In R, functions are just another type of variable, so we can create our square function the same way we create any other variable, with the name of the function and the arrow assignment operator. To define a new function, we use a function called, unsurprisingly, function. As arguments, we provide a list of the arguments that we want our square function to take. For now, our function will just take one argument, x, the number that we want to find the square of. Now, we need to set what the function does. To do this, we create a block surrounded by curly brackets. The code inside of this block will determine what the function does. Inside the block, the argument or arguments provided to the function will be available as variables. Whatever value is returned by the code inside the block will become the value returned by the function. This function is for finding the square of a number, which is provided as the argument x. So let's write a single line of code to calculate and return the square of the variable x. Now let's run the code to create our function. We'll test if our function works with a few examples. The square of 2 is 4, the square of 16 is 256, the square of negative 10 is 100. Fantastic. We've created our first function. Now, let's create another one that is a little bit more complicated. This function will be called greet, and its job will be to print out a text greeting to the user. It will take two arguments. Name, the name of the user, and salutation, which is the greeting that will be used. Inside the function's code block, we'll use the paste0 function to create the greeting. Now let's run the code to create our function, and we'll test it in the console. We'll say our user's named Alice, and we want to say good morning to Alice. So far so good. However, there are a couple of extra refinements we can add to our function. The first is the default value. A default value for a function argument is the value that the argument will take if the user doesn't provide that particular argument. It's set with a simple key-value pair when defining the function arguments. Let's set a default value for the salutation argument, hello. We'll run the code to create the function again, and this time we'll run our function containing the name, Alice, but not a salutation argument. As you can see, the default value of hello has been used as a salutation. However, we can still provide our own salutation if we want. Now let's consider something else that might go wrong with our function. What happens if we run the function with no arguments at all? R returns an error, because when the paste0 function tries to paste the salutation and a name together, it finds that the name variable doesn't exist. How can we get around this? R provides a simple mechanism for checking whether an argument has been provided to a function. It's the missing function, and it returns true if an argument is missing. To see the missing function in action, let's temporarily replace the contents of our greet function with a call to the missing function. We'll use the number sign or hash key to turn the paste0 line into a comment that won't be run. We'll use the number sign or the hash key to turn the paste0 line into a comment that won't be run. Now we'll run our code to create the new function, and we'll see what happens if we run the function. First, we'll run it in the expected way, with the value provided for the name argument. The function returns false because the name argument is not missing. If we run the function with no name argument, the function now returns true because the name argument is missing. So, what we need to do is insert some code into our greet function that notices if the name argument is missing using the missing function, and produces an appropriate error message. To do this, we use an if block. An if block takes an expression and a block of code, and executes the block of code only if the expression is true. For this if block, we want the code to be run only if the name argument is missing. If the name argument is missing, we use the stop function to stop the execution of our greet function and return an error. We'll also remove the comment from our paste line to ensure that the function still performs its intended job. Let's run the code to create the function, and now let's see what happens if we run our greet function without any arguments. Excellent. This time it returns an informative error explaining what went wrong. Now, let's confirm it still works as we intended. Fantastic. We've created a flexible, usable R function. Here's an exercise to test your understanding of this video. As always, a worked solution is provided in the code file attached to the video. Exercise 1. Create a function that takes two arguments, x and y. The function should return true if y is the square of x, and false if it is not. The function should return an error if either argument is missing. In the next video,